Now, it may seem rather premature to be taking a look ahead at the next generation of mobile network when the 5G rollout is very much still a work in progress. What 5G really shows us, though, is that we're on a journey towards much tighter coupling and integration between mobile networks and cloud services. Now, when we talk about cloud here, we're talking mainly about the cloud architecture. So with 5G standalone, for example, the 5G core network utilizes microservices running in a containerized environment, whether that's in a private or a public cloud configuration. And we are also seeing greater integration with public cloud services provided by hyperscalers such as AWS, for example. Now, it's quite useful for us to take a look ahead to kind of ponder on how much tighter that integration will be and the significance of cloud computing to the next generation of mobile network and indeed beyond. So if we take a look here, we can see some quite significant use cases, some of which have been mooted as potential use cases for 5G. But as we're seeing, many of these have not progressed to a commercial reality. So it may be that as we step forward into the next generation, that we really start to see these use cases emerge. So if we take smart city, for example, or indeed any large deployment of cellular IoT, there are going to be many devices that will place demands on the network in terms of capacity. There will be a requirement for large volumes of data to be transmitted and processed. And this is something that we already see happening now within the cloud. We may see devices deployed at the edge of the network as gateway or data aggregation devices. And certainly the success of Smart City, for example, will be dependent on the ability to offload processing into the cloud or at the network's edge. Next, we've got digital twins. This is this idea of being able to provide a digital replica of a physical system. And this is useful when it comes to applications such as training or modeling, for example, where it's useful for us to be able to manipulate a digital version rather than a physical one, because this may have cost or safety implications, for example. And once again, what we're going to need here is a significant degree of processing that may not be feasible to have on site. So once again, this is a use case where we may see some offloading of that processing into the cloud to really benefit from those economies of scale that we do see from cloud computing. We've got real-time applications such as extended reality and virtual reality. So we may have sort of low-power, low-cost devices that need to carry out image processing, for example. And once again, we're talking about offloading that processing into the cloud. It may be that additional services can be provided from the cloud to the device. And there may be many other potential applications for this. And then finally, though this seems very much the work of science fiction, there have been lots of discussions and research around this idea of holographic telepresence. Or put more simply, a more enhanced version of the type of conferencing communication that we see today. So with this, we will have the ability to project a high quality image of a speaker, for example, into a physical environment populated by other members of staff that may be in that same meeting. So this is a much more immersive conferencing experience. And again, this will be relying on a number of different cloud and edge computing technologies potentially. So now let's take a look ahead at some key concepts that we might expect to see in a future cloud and future mobile network integration. So AI and machine learning, we can expect to see much more of this in use within the network. So in terms of managing the network itself and allocating resources, for example, but also in terms of providing services to end users. We've got this idea of pervasive connectivity. And we should also say there is also the idea of pervasive AI. And we often see this used and often interchangeably with the term ubiquitous. So we might see ubiquitous or pervasive connectivity. This really is just the idea that we can be connected wherever we are, that any handoffs between different connectivity technologies are as seamless and invisible to the end user as possible. So we can expect to be connected wherever we are. Cloud to edge infrastructure. Now, we often talk about MEC or multi-access edge computing as being a key enabler for some of the low latency applications that have been proposed for 5G, and this will certainly be significant in the next generation as well. So over the next decade or so, we can expect to see cloud moving from a closely centralized model to a much more distributed model as hyperscalers start to move their resources out to the edge of the network to provide services to support edge computing. And then this idea of ubiquitous computing. So this is the supporting many different devices, the home of the future, the workplace of the future, for example. We can expect to see huge amounts of connectivity and devices all communicating with one another. So if we take a look at this idea of pervasive or ubiquitous computing, and really these two terms can be used interchangeably. So some key ideas here then. So big data. We can expect to see huge volumes of data being generated by the networks themselves, being generated by devices that utilize the network. And this is really useful for a number of different applications. So this may be used by mobile service providers themselves to analyze their network, to provide potential new services to particular customers, for example. And we can also expect to see artificial intelligence deployed alongside this data to really make sense of these huge volumes of data that wouldn't be feasible for human beings to sift through and make sense of. We've got multi-access edge computing, as we've mentioned several times already, so we can expect this to be a significant contributor to this idea of kind of ubiquity or this pervasiveness of computing. So devices, will establish communication not necessarily across the network and across the internet, but possibly with application servers deployed at the edge of the network. So things such as IoT, which we've mentioned already, we won't go over again in too much detail. And then we've got smart environments, things such as smart cities, smart workplaces. And then moving on to the final point here, we may even see smart healthcare settings where we have devices monitoring the health of patients, devices that are useful for diagnostics, for example. So really, we can expect to see computing become much more embedded as we move forward into the next decade or so. So now let's take a closer look at the role of artificial intelligence. Now, already we're seeing the use of AI and machine learning within mobile networks with 5G. So this may be used for things such as analytics and network troubleshooting, for example. But we can expect to see AI play a greater role. And I alluded to this just a moment ago in terms of providing new services. So we may be able to analyze how customers utilize the network and provide tailored experiences for them. Now, in terms of AI, we may look at this in a number of different ways. And the key thing here is, what questions can we ask that can be answered through the use of AI and machine learning? Now, in a predictive model, we're able to speculate on what will happen, and this can be useful for things such as predictive maintenance or network troubleshooting, for example. And then prescriptive, so in the event of something taking place, we can utilize AI to take action. So if you think about things such as security, for example, we can utilize AI to look for suspicious activity on the network, and we can then be prescriptive. In other words, the AI is able to take action to resolve this issue or to mitigate this threat. And really, we can see both of these fall under the guise of machine learning. So in other words, these models will need to be trained by utilizing huge amounts of data to ensure that they are able to make the correct decision. And of course, there are a number of different legal, ethical, and regulatory concerns when it comes to the use of AI. And certainly this may be a challenge to its future implementation as different governments throughout the world will introduce new legislation that may be designed to limit the use of AI or to control the use of AI in some way. And we can see that AI has a number of key use cases within mobile networks, some of which I've outlined already. So certainly the use of analytics. There are already commercial products out there within 5G that utilize AI and machine learning for analytics purposes. We may see it used for resource allocation. So as I've already alluded to, AI is running in the background, it's monitoring the network, it's able to take different actions depending on network conditions to ensure that the experience is optimized for the subscriber. And then energy management. So we may see this deployed on the radio access network side where things such as transmit power, for example, can be controlled by an AI model. Now, in terms of big data then, so we've touched upon this already, but we can see there are a number of different ways that mobile networks will be able to utilize the huge volumes of data that we expect to be generated in future mobile networks. And when we consider there will be a huge explosion in the number of devices that will access mobile networks via different means, so when we've got IoT devices, smartphones, we may have other devices that will utilize that cellular connectivity. So the volumes of data are likely to increase significantly. So as I mentioned already, this can be used to optimize network usage and services. It can be used for increased security. So we can use this to train machine learning models to look out for specific threats and unusual activity and to take action. We've got product innovation. So the use of big data will allow mobile service providers to provide tailored applications or tailored services or experiences to particular groups of users, for example. So if we can target particular users that are heavy video users, for example, or heavy users of traffic related to gaming services, then clearly this allows us to target new experiences and services to these subscribers in a much more focused way than we may have seen previously. And finally, we have BI, or business intelligence. So this huge amount of data can be analysed to inform key decisions taken by mobile service providers, for example. So we may be able to look dynamically at things such as churn rate, for example, so the number of subscribers lost. It may be that by being able to target those customers in a particular way, we can ensure greater retention. And there are indeed numerous other ways that data can be used to make informed business decisions on how the network should grow or how the network should be managed. Now, another key technology that is likely to be significant in future mobile networks is multi-access edge computing, or simply edge computing. Now, when we talk about the cloud, we often talk about this model of centralized services, but really the next natural step for many hyperscalers, such as Amazon Web Services, such as Microsoft Azure, is to offer edge compute capabilities. And indeed, we're already seeing this. So if we take AWS, for example, they're able to provide local zones and regional zones where services are available in particular geographic locations. Now, the significance of this is it allows for us to deliver low latency services. It allows for things such as offloading of processing, for example, or the aggregation of data that doesn't necessarily need to cross the entire network or to cross the internet. And where we may have a multitude of different IoT sensors, for example, they can simply communicate with an application server deployed at the edge of the network, and thus this reduces overall network load. So we can take a look here at a typical model for MEC. Now, what we may see is we may also see public cloud providers provide edge compute capability for things such as, if we think about centralized RAN or cloud RAN. So with the radio access network, we may see things such as the centralized unit deployed within a regional or a local data center, for example, alongside services that are part of the core network. So we may see the user plane function, as we see in 5G, deployed at the edge of the network to provide that connection capability to customers. So we can see there are a number of different applications that will be able to benefit from the low latency provided by MEC. So things such as autonomous vehicles, things such as drones, for example, as well as traditional smartphone users. Now, as we can see, there are a large number of use cases that are able to utilize the capabilities provided by edge computing or multi-access edge computing. And of course, there is an opportunity here, and we're already seeing this with cloud providers providing resources, compute resources, networking resources, much closer to the edge of the network. Indeed, in some cases, we may even see things such as application servers deployed alongside radio access network infrastructure. So the key point to make here is that in future, we're likely to see a much greater integration between mobile service providers and cloud providers. So we may see the sharing of investment, for example. It may be that there is a business case for cloud providers to provide edge compute services to a number of different mobile service providers. And indeed, we're already starting to see this kind of as a slow drip where companies such as AWS are able to provide compute, storage, and networking resources on a much more localized or regional basis. Now, IoT is an area of significant growth. Indeed, we're already starting to see this with 5G. We can expect this to continue into the next decade, where we can expect to see many more IoT devices deployed within environments such as smart cities. For example, we may even see ambient IoT devices that are able to effectively harvest their own power and operate without any form of battery power for significant amounts of time. This may be useful in things such as remote and hard to reach environments, for example. And then we've got things such as wearables, so we can expect to see IoT devices embedded within things such as clothing or footwear. This can be useful for things such as tracking athletic performance, for example, or tracking fitness levels. But we may also see applications in healthcare where patients are able to be remotely monitored. Now, it stands to reason that this will require reliable connectivity, but this may also generate volumes of data or data that needs to be analysed and processed in a central location. So this may be a healthcare provider, for example, may aggregate and process huge amounts of data from individual patients in a healthcare setting. And of course, we need the connectivity to be reliable, but we also need reliable storage for this data, reliable processing resources, for example. Now, virtualization is already a key technology in 5G networks, certainly on the core network side, where we're seeing the use of virtualized network functions or cloud-native network functions, as we sometimes refer to them as. And these are effectively software-based microservices that carry out the different network functions. And in previous generations of network, these may have been carried out by proprietary hardware, for example. So we're seeing a shift towards more software-based solutions, since these bring much greater flexibility. Now, this isn't something that we're only seeing on the core side. Indeed, we're seeing a greater convergence between core and radio access network, as in centralized or Cloud RAN, for example, we're able to separate out the distributed unit and the centralized unit. So the centralized unit can often be located in a data center, either in the public cloud or on premises, alongside elements of the core network. And indeed, with the distributed unit, we may see the user plane function deployed at the edge of the network to provide that multi-access edge computing functionality to devices. So this is something that we can expect to see continue. And indeed, one of the approaches that has been mooted when it comes to rolling out the next generation, whether that is 6G or whether it comes under a different name, is via a software upgrade. So in theory, future networks will simply be a reconfiguration via software of both core network and radio access network. So there are a number of different ways that we can do this. So potentially, we can deploy new modulation schemes via software without the need to actually modify or change the radio hardware itself. Now, there are a number of challenges to overcome here, and this will of course be dependent on the equipment that has been installed as part of the 5G rollout. But certainly this is an approach that is gaining some traction, and virtualization is the underlying technology that will facilitate this type of approach. So in closing then, we are likely to see significant convergence and integration between cloud architectures and mobile networks as we move into the next generation of mobile technology. We can also expect to see the cloud model itself change. So whilst there will always remain a market for centralized services such as those that we see already, we are already seeing large cloud providers moving into providing more localized and regionalized services at the edge of the network.